Hello, everyone. So let me just share my Jupyter notebook. Yeah, so what I want to do today is, so I received quite a few questions about different projects, if some projects are good and if some projects are not good. And some people want to do multi-class classification, some people want to do something with text and so on. So what I wanted to do today is to show you some things, like let's say somebody wants to work with text, and then you will get to review that. For you not to feel completely lost, I want to do basic introduction into some of these things. So you don't have to use text, but in case you have to, you get a project which you need to review, and it will contain some text. I asked in these cases to describe as much as possible, to give a lot of description and explain what's going on. But I thought it would be a good idea if I explained some things now during office hours. So this way for you, for those who haven't used any of these things before, it will be easier. So what I want to cover today is talk a bit about multi-class classification. This is, so in the course, we covered binary classification. And multi-class classification is when instead of just two classes, churn and not churn, for example, we have multiple classes. Like, for example, could be cat, dog, and I don't know, a car. So 3 classes, for example, or something like this. So basically when we have more than 2 classes. Then I want to talk a bit about feature importance for continuous target. So when we have a regression problem, so how do we evaluate important features? Because in the lectures, we talked about the case when the target variable is binary. So here we will talk about the case when it's continuous, when it's a number. Then I'll show you how you can work with text, and finally, how to evaluate your models when there is some time component in the data. So just 1 second, let me see how many people joined already. Yeah, so I think I should start. So for this today, I'll use the Airbnb dataset that we already know. And in the homeworks, we used only a subset of features from this dataset, but there is more. We actually have name, for example, which is a text variable. Yeah, so there are some variables that I want to show you how to use. So let's start. I will load this. So first I need to import pandas and numpy. And then I read the CSV file. So it's AB. And then I will read only some rows, not all the rows. So I will read 3,000 rows. Oops, it's n rows, I think. Yeah. So now we have a data frame with only 3,000 rows and all the columns. So this is how it looks like. And so here in this data set, remember, we want to predict the price. So this is the variable we were predicting previously, so this price. So what I want to do now is I want to change it slightly, and I want to predict the neighborhood or like a district. So we have this neighborhood group from New York. So if it's Brooklyn, Manhattan, or something else. And the features we can use for this is latitude and longitude. So I think it should be relatively straightforward to map from latitude, longitude to neighborhood group for some models not. So what I want to show you how to do is to build a model for that. And neighborhood group, let's see, neighborhood group, value counts. So there are quite a few different ones. So we have Manhattan, Brooklyn, Queens, Queens, Bronx, and this island. Okay, and we see that there are not so many of these. So let's just take the first three, and we will build a model that will try to predict based on based on the geo coordinates. It will try to predict the neighborhood group. So we'll take these first three. So Manhattan, that's the first one. So these are the variables, these are the neighborhoods, districts that we are interested in. So just these three. And then let's filter. So I want to keep only the neighborhood groups, only the records for which neighborhood group is one of these three. And for this, we use isIn function. Groups. So let me show you what it does. Of course, I don't have groups yet. So it will return a series with true or false. True if this value is one of these three, and false otherwise. And then we can just keep data frame, like filter the data frame. So this way we will keep only records which are one of these three. Yeah, and let me reset index. Okay, so we have our data frame now, and we should only have, so let me move it here. So we should only have three, right? And now remember is features. Let me see. So we have latitude and longitude, right? So we will use this as features. Latitude, longitude. So these are our features values, right? Let's call it X. So we will not do splitting between train and test. Just for simplicity, I want to show you how to do this in principle. Of course, you should always do the train validation test split. I'll just show you here, and I will evaluate this on the training data as well. Okay, so we have that, and then our Y will be data frame, neighborhood group, also values. So this is our X, and this is our Y. So Y here is not a binary variable. It has three different values. And what we want to do next is from scikit-learn, we want to train a linear regression model. From scikit-learn, linear models. So now why my autocomplete doesn't work. Import models, import. Logistic. I hope I don't have any typos. That's interesting. I have a fresh, I probably have a fresh installation of my Python. Scikit-learn. So let's see if I need to install it. Yeah, that explains why it doesn't. For some reasons, it installs an older version, but that's fine. And by the way, so here, you know that if you use conda for installing things, it asks if you want to continue or not. So you cannot really use Jupyter for that. So you need to use this from the terminal. But if you add -y, it means you agree. So it doesn't ask you whether you want to install or not, it just installs. Okay, so now hopefully it should work. Linear. Cool. So logistic regression. And here, I don't think we need to change anything. Yeah, so it should work with this multi-class data out of the box. X and Y, and that's it. You see, it trained the model. we can now see the coefficients. That. It's very difficult without autocomplete. I don't know what's going on. Yeah. Okay, let's see what it has. Class it's coef with one f. Okay, and these are the coefficients. And remember in the case of binary classification, we had coefficients that was a one-dimensional array, and here the array is two-dimensional. So yeah, it was actually two-dimensional with one row only, but here we have three rows. So what actually happened is internally in logistic regression, we trained three models, one for each neighborhood. So we trained one model for Manhattan, we trained one model for Brooklyn, and we trained one model for Queens. So internally we had three models. And then, and each model predicts a binary classifier model. So each model is it Manhattan or not Manhattan? Is it Brooklyn or not Brooklyn? Is it what's the last one? Queens? Is it Queens or not Queens? And that's why we have a two-dimensional array with coefficients. So these are the coefficients for the first model, for the Manhattan model. These are the coefficients for the Brooklyn model, and these are the coefficients for the Queens model. And the same with intercept. So intercept, hope I typed it correctly. Yeah, so we have three different bias terms, one for each model. And when we do predict X, we actually get predictions, or we can get predict proba, and we get probabilities. So the first one is probability that this record is from Manhattan. The second one is if this record is from Brooklyn, and the third one is if this record is from Queens. Right? So let's just use get hard predictions. And so these are predictions, and we can see how accurate these predictions are by using accuracy. So this is the same way for evaluating as we used in the lectures. And the accuracy of this model is not super impressive. It's 68%, but for a linear model, it's difficult to classify it correctly. Okay, what we can also do is tree-based models. They can also do multi-class classification. So let's do this from scikit-learn tree import decision tree classifier. I need to type from memory. Okay. So then what we do next is we will just train a decision tree model with default parameters. And yeah, so I just copy that. Decision tree. Yeah. And it's very similar. So we do predict X, and then we get a prediction. And if we check accuracy of this model, mean, it is 100%. And again, the reason here is that we didn't restrict the depth of the tree. That's why it trained an arbitrarily deep model, basically the same situation as we had in the lectures. So this model is super accurate. We can restrict the size of this model, max depth, let's say 5. And then with 5, it's still quite accurate. Let's try 4. Yeah, so it's decision tree is able to handle this situation much better than logistic regression, and because of the structure of a tree. So if we can see now, we can actually visualize the tree. I think it's was it export tree? Export text. DT. I think I need to print it. And I also need to give feature names. Okay, feature names. And the feature names for us are latitude and longitude. And yeah, so the way decision tree works is, okay, if latitude is less than this one, if longitude is less than this one, so it basically, so it gets them up here. So let's say this is, oops. So let's say this is the map of Manhattan, and it says that if latitude, so let's say this is lat, this is long, and it says that the area here and here is Manhattan, right? So for decision trees, it's a lot easier to make this split. You see, so it says latitude, longitude, and longitude, and latitude, and they basically narrow it down to some area like here, and they say everything that is here is Brooklyn, right? That's why they are able to achieve much higher accuracy than logistic regression. So this is how you use linear models and tree-based models for multi-class classification. For XGBoost, it's actually very similar. And yeah, so the next one I wanted to talk about was feature importance for continuous target. So let's do that. So here we have our data frame, and we have the continuous target, which is price, right? So this is our Y that we wanted to predict in homework. So what we want to do now is we want to understand the importance of different features for this problem. Because in the lectures we did feature importance analysis for binary variables. So now let's try to do the same for continuous ones. So for that, I first want to find all the numeric columns. So everything that is not an object. So then let me just do that. Index. Yeah, so these are all numerical variables. Let me call this numeric. And we don't need ID. We don't need price. So the rest, I think these are the features we used throughout the course, right? So these are the numeric features. And then we can calculate correlation for, like we have two cases. We have cases when our feature is numeric and target is numeric. So for these cases, we use correlation. So let me write it down. So numeric. So this would be feature. And this would be target. And for this, we use correlation coefficient. So this is the same that we used before in the lectures, except there the target was binary, but we use the same code here. I think it's core width, data frame price, and then it gives us correlation. We can take absolute value, and this will, oops, typo. Oops. And this will take us absolute importance of numerical features. And probably when we predict price, we will predict actually logarithm of price. It's 1p. yeah, something like this. So then we see that longitude actually seems important, more important than others. Number of review interviews per month, they're slightly important, very slightly. And then the rest are like very, like not really, they don't really correlate with price at all. And so this is how you see the importance for when the feature is numeric and the target is numeric. And then we have the other case when a feature is categorical and target is numeric. So in the lectures, what we used mutual information. And there in the lectures, the target was also categorical and the feature was categorical. So what we can do here is we can turn this numeric feature into categorical. And then we can use mutual information. So this is what we already did. So we just need to find a way to turn numerical variable into categorical, and then we can use the tool that we already know, which is mutual information. For doing this in pandas, there is a function called cut, which let's take this price. And we say that we want to cut the price. So we take the price and we cut it into 10 different intervals. Let's say 10 means 10 different intervals. So it gives us intervals between, so let's say we have our price. So our price looks like that, right? So very long tail. So what it does, it splits this into a number of intervals. And then, so this is the first interval, second interval, third, fourth, fifth, and so on. And then, yeah, so this way it cuts the numerical variable and turns it into categorical. And yeah, so the first bin we see is a price between 5 and 500, right? And what we can check now is how many different value counts, how many different value counts are there. And we see that the majority of prices fall into this bucket, which is not super useful because we know that this is for us, this is the head of the distribution and this is the tail, and only a few observations are in the tail. So this one is not super useful for us. We of course can do logarithm log1p, which improves the situation slightly, but still we see that you know, these two, they contain a lot of observations, these two fewer, and then it's less and less. So I think what we have there is a distribution like that. Perhaps it's a normal distribution, right? And then so we split. So we split something like this, right? And so this one is 4.8. So this one, these two have quite a lot of observations. So these are the first two. Then these two are here, right? So they have fewer observations, and then even less here and here and so on. So they get fewer and fewer observations. So this is also not super useful for us. It would be useful to take like a distribution like that and cut it into equal pieces. So let's say we get 10% of data here, then I don't know, 10% of data here, 10% of data here, and so on. So we cut it into bins that are equal in size, right? So each bin here gets equal amount of data. And for that, in pandas, there is a qcut function. Qcut means quantile cut, I think. So basically it uses quantiles, and quantile is, let's say here in the distribution, we have 0th quantile. Here we have 10 10th quantile. Here we have 20th quantile. So we basically have all these quantiles in data, and median is quantile 0.5 or 50%. So this is median. And we use them to actually do these cuts for us. And I think here instead of bins, you use Q. And when we do it this way, so the bins are slightly different, but you see they are more like they are better, more equally distributed. Right. So for this one, maybe we don't even need the logarithm. See if we don't sort. I think it's sort false. We see how it looks like. So you see for this bucket with the long tail, basically the entire long tail gets into one bin, right? Okay, and this, let's say we can call this variable Q price. So this is again how it looks like. So basically each observation is mapped to one of these bins. And this is a categorical variable with 10 different values. And now we can use mutual information. Can use mutual information. It's from scikit-learn metrics, import mutual info score. And so mutual information score. My autocomplete works. Is strange today. So what kind of variables we had? I don't remember. So we had the neighborhood group. So let's use that one. And we want to see the importance of this feature for predicting the price, right? And this is the mutual information. And then we can compare it with other variable, let's say neighborhood. I think this is a part of the neighborhood group. So specific neighborhood. And we see that mutual information score for this one is actually higher. Because I guess if we talk, let's say, about Brooklyn, there are neighborhoods that are more expensive. There are neighborhoods that are less expensive. So it means it makes sense that for a more granular level, they have they are able to predict price better. And then we have another variable is room type. So let's see how important room type is. So it's almost as important as neighborhood. It's slightly less important. So this is how we can see the importance of different categorical variables for predicting the price by cutting the price, by turning the price into a categorical variable. Okay, then the next one, working with text. Let me just pause for a second and see if there are any questions. Okay, so the only question there is when are we going to have lesson about deep learning? This will happen next week. Okay, so next one is working with text. So in this data set, we also have a text. This where is it? Host name, neighborhood. Yeah, the name one. The name variable is text. So this is the title for the listing. So let's take a look at this name. So yeah, this is what you see in Airbnb in the title. So it says this one is clean and quiet apartment home by the park, Central Park probably. So let's say we want to use this this text now to make our predictions, right? To also use them as features. So what we can do is we can use an approach similar to one-hot encoding, where for each word, so remember in one-hot encoding, for each variable, we had a column which was hot, like meaning we put one there if this record has this value, right? We can do something similar with text. I'll show you, you'll see this, like I think it's better just to show you than try to explain. So let me take first 3 records only. So this will be our names variable, names. So we want to take these three records and see how we can turn these records, extract text, and use this for machine learning models. So for that, in scikit-learn, there is a convenient thing called count vectorizer. It uses, like I will just show you. So it lives in feature extraction.txt package, import count vectorizer. This is very similar to one-hot encoding that we saw. Let me just create this count vectorizer. Count. And then we fit it on names. So like we do with dictionary vectorizer, count vectorizer is doing something similar. And then let's now transform it. Transform, again, names. And it creates a sparse matrix. We want to see what is inside this sparse matrix. Let me just call it X. So to do this, I think there is a method called toArray. Autocomplete doesn't work for me. Okay, so toArray, it shows that the text, this one, so clean and quiet apartment home by the park, is represented by this array. So there are ones for each of the word. So let me also see, I think count vectorizer, get just feature names. My autocomplete doesn't work. I think it's just feature names. Yeah, right. So here, this the first column is apartment. So the first word, the first record has the word apartment in it. Where it is? Yeah, apt. So that's why it's 1. Then the second one is by. So it also has by in it. So that's why it has 1. And so on. So basically for each word, if the word is there, it gets 1. If the word is not there, it gets 0. We can actually turn this into a pandas data frame to make it easier to see what's going on. So columns here will be these features. Now, so you see, then for this record, I just print it also here as well. So this one has the word clean. So here the word clean, and you see the ampersand, this end thing is not here. So scikit-learn strips off like removes all the punctuation. And of course, this could be configured. I will not go into details how exactly you can do this. You can check documentation. There is a lot of interesting stuff here. So I'm showing this to you to, like, if you are reviewing a project, like you don't have to use text actually in your project, but if you're reviewing a project and somebody uses text, and I'm sure that there will be at least one project with text because they approached me and asked me if it's okay to use text. I said, okay, but be sure to explain everything that you're doing. So if you see something like this, you will already get some idea what's going on there. And actually, count vectorizer is not the only vectorizer. So it's likely that you will encounter maybe this TF-IDF vectorizer, which is very similar to count vectorizer. Let me just replace it. It's very similar to count vectorizer, so it's doing the same thing. So it turns, again, like for each word, it creates this for each. So it splits the, it turns the piece of text into, again, an array, but it looks a bit different. So you see here, instead of ones and zeros, it uses a number like that is not 1. So let me round it a bit. And what TF-IDF is doing, so here it's called TF-IDF vectorizer because it uses a special weighting technique for words, which is called TF-IDF. You can Google it, TF-IDF, and you can read about this. it describes what's actually going on here. But the main idea that for important terms, so the main idea here that for important terms, it gives more weight than for less important terms. So if we, for example, have a word by, which occurs in many, many documents, the word by is not as important as, let's say, a work of the word of, I don't know, Midtown, for example. Midtown is more important. Yeah, that's the main idea behind TF-IDF vectorizer. So you can read more about this in Wikipedia, for example, or just Google this and you will find a lot of nice resources about this. Yeah, and this is how you turn text into matrices for using, this is one of the ways. There are others, more complex, that use neural networks, but this one is a basic one and it's very similar to one-hot encoding. And then the final thing I wanted to talk about was evaluating your model when there is time information. So for that, actually, there is not time information in this data set. I just want to draw something. So let's say we have a data set and we have some time component there. Time. So one of the questions I received was in Slack was if we can use a data set for predicting what was that, sales of some store, something like this. So this is more like a time series kind of data. So they have like a day. For example, today is 25th of October, right? And then they have 24, they have 26, and then for each day they have, I don't know, sales in the store. Right. So this is, we can think of this as a regression problem. It's more difficult. I will not go into, it's more complex than that. I will not go into in details about that. So there are different families of algorithms that work well for time series models. So what I want to tell you that in this case, if you're working with a data set that has some time component, let's say I'll just draw again. So it could be January, and then February, then March, and so on, and then December. So if you have a data set like that, and you have time there, instead of using, like remember the usual way of doing this for us for preparing this terrain validation test split, is we just take everything we have, we shuffle it, and we take 60% for train, right? 60% for train, 20% for validation, and 20% for test. But in case we have time component in our data, we don't shuffle. So what we do is we take, let's say, data from January till August. I think August is 8th month, which is like 60% of data, which we use as train. Then we take the next 20% of data as validation, and then the last 20% of data as test, right? So we don't shuffle in this case. In case we shuffle, yeah, we can accidentally break this time component and time, like this time information, and we, yeah, we will kind of look ahead, right? We will get some information in the future. But what we actually want to do is we want to train a model on the past data and see how well it does for predicting the future future things, right? So, and the only way to see how it actually works, how the model is able to sort of predict the future, is to do this time-based split, right? We don't shuffle here. We basically use time for deciding what goes to train, what goes to validation, and what goes to test. So if you have, if for your midterm project, you're working on a data set and you have time there, be careful and try not to just shuffle everything and use a time-based split. And we saw actually in week 2, when we were working with regression, how to implement this manually. In scikit-learn, it's also possible, I think, to not shuffle. I don't remember. yeah, you can just check. Maybe I'll quickly Google train test split. Maybe this one, actually, there is a parameter that says don't shuffle. Yeah, so this shuffle bool default true. So you can just set it to false, but you need to make sure that before you invoke this train test split, the date is already ordered by time. Yeah, I think that's all I wanted to cover today. So let me see if there are any questions in live chat. Yeah, I don't know if my YouTube doesn't work. I don't see any questions after the one about deep learning. Anyways, let me go to Slider. So just save this notebook just in case, because I saw that the first thing that was there, please make available today's notebook. I just saved it and I will upload this. For hyperparameter tuning, should I be tuning using the full train and test dataset? No, you should not. You should use the validation dataset for hyperparameter tuning. And you tune your model using the validation dataset. Then at the end, you join the train and validation dataset to train your final model. So you do not tune parameter on the test dataset at all. So you use test dataset only occasionally, very infrequently, only to double check that you don't accidentally overfit. When you have your final model, then you use it, preferably only once. So you try to not look at this at all. So for hyperparameter tuning, you use the validation dataset. The next one, if features correlate highly with label, is it recommended to drop them in order to avoid leakage? If drop, any risk of losing relevant features? It's really case dependent. So I saw in Slack, I think from Carlos, if I remember correctly, he asked if he needs to drop features or not. And there it seemed okay not to drop. So the highly correlated feature was the, I think, assistant name, and then the target variable was churn. So basically, there people who work with one particular person tend to churn less than people who work with other somebody else, right? I think in this case, it seems like a relevant feature to include. Yeah, so I don't know, it's really case dependent, and usually you need to have some sort of domain expertise to decide if this feature introduces leakage or not. So in Carlos' case, I think it's safe to leave it. But then again, if you drop, so you can just see how your performance on validation dataset changes. And then this gives you some idea how important this feature is. Yeah, so it's case dependent. I want to do feature engineering, adding a new categorical feature and random undersampling to balance my data. Which process should I do first? I don't think it matters actually. Yeah, I think these two things are quite unrelated to each other. So you can add a categorical feature to the entire data set, or you can take the categorical feature to a small sample. And yeah, I don't think it will. Maybe first taking a sample and then doing feature engineering is better, because simply your data set is smaller, so you can do these things faster. But yeah, I don't think it actually matters. As a part of deliverable, we expect the peer evaluator to download, clone Git repo, and build Docker image and run Docker container in localhost cloud. I don't know if it's reasonable to expect. I think it is. Like, I really want you to run it and learn from this. But if you remember, I don't think I have the evaluate. Let me just quickly open Git. Like if you look at the evaluation criteria, so I think I have them somewhere here. Midterm project. Yeah, so these are the criteria for evaluation. And it doesn't say that, okay, this is not runnable. So ideally you should do this. You should be able to do this and do like do git clone, do Docker build, do Docker run, right, and test that it works. Yeah, so this evaluation criteria do not ask you to do this. You can just see what is there. So for example, the criteria here that it's there is code for deploying, or it Docker file is provided, and README clearly describes how to actually build a container and how to run it. So if you want, you can clone it, and there should be no errors. Actually, maybe I should also add a section about errors here, but yeah, it's up to you actually if you want to run it or not. I advise to run, but I also recognize that maybe for some of you, it will require too much time. If you need to run 3 different projects and some of them do not run, it might be difficult. So I will leave this decision to you. So if you have time, if you want to learn from others, I highly encourage you to actually run this, but it's I would say it's optional. Do I do EDA first and then split data, or split the data and then EDA? Which data do I need to do EDA? Train full data. Yeah, so ideally, as I said, you take your data set, you leave aside training a test data set, and you don't touch it at all until you have your final model. Yeah, so you don't do EDA on your test data set. So you can do this on train, you can do it on full train, up to you. Just don't do this on train data set, because you can accidentally see a pattern there and yeah, try to use it. Like maybe build a feature around this pattern, and this pattern might not be true in the general case, right? So try not to, it's called data snooping. So when you look at the data, you might accidentally see something, and this something seems very important, and you just accidentally overfit. So try to avoid looking at the test data set. What changes are required to host and port settings in Python script, both Flask and request script, if we deploy our container to cloud, say Heroku? It really depends on the cloud. So you saw how to do this. So I showed you how to do this with Elastic Beanstalk. I don't think I needed to change much there, if anything. Yeah, I don't remember changing anything there. So the only thing I changed was the URL in for the service. So in this test.py script, that was the only thing I needed to change. I think for Heroku, it's similar. Actually, if I go back, so there are a couple of tutorials. If I go to deployment, so there is a tutorial about using Python anywhere, and tutorial about using Heroku. And they probably explain you what you need to change here. Yeah, just go through this and see if you need to change anything or not. Seems like here you don't need to change much. And let's see, Heroku. Yeah, I think you can just go through this and see if you want to change anything or not. I'm probably not much. How to parse a list of features in string to usable variable columns? I do not know what you mean. Maybe you can post an example in Slack, and then we can take a look at this together. Could we extend the project deadline to 1 day? Most likely no, because I think it will complicate the logistics. But I also want to see how many people actually manage to submit by the deadline. and then make a decision. But I am a bit hesitant to extend the deadline. And the reason for that is, remember, we have a third project. So if you, for some reasons, do not maybe have time now because of some reasons, you can still do this project, but just a part of the third project, for example. Because to be able to get a certificate, you need to do 2 projects out of 3. And the reason we have third project is exactly for this. Like maybe somebody is a bit behind, you still want to take part. That's why, like if you don't have time now, you can do this as a part of the third project. Should we be using cross-validation? It's up to you, honestly, if you want to use cross-validation or not. I think you should, but you can also use just usual train validation split. With cross-validation, you get, as a bonus, you get, you can see how stable your model is, like what is the standard deviation. Usually it's useful. Yeah, so I would suggest to do this, but I do not require you to do this. So cross-validation is useful, but there must be some form of validation, because without it, you will not be able to select the best model. Any tips for working with really large data sets? Yes, so use linear models. They usually are quite good for large data sets, better than, let's say, tree-based models. And then another tip is there is a SGD classifier. It's called stochastic gradient descent classifier, which is also for linear models, which is faster than a usual logistic regression. Yeah, so because it can look at a part of data when training, it doesn't need to have the entire data set in memory. So yeah, for large data sets, you can use this, or you can just go to Amazon and rent a bigger machine and just train XGBoost there, and this will probably be better than trying to train a smaller, like a linear model on your computer. Also, you can do sampling. So let's say if you have a pretty large data set, you can take a sample of, I don't know, 10,000 rows, and it should work reasonably well. So, and again, it's case dependent. How to handle imbalance in datasets? So there are multiple ways. So first is you don't. So you just train a model as is. You just need to be careful not to use accuracy as your metric, evaluation metric. You use precision, recall, F1 score, AUC, and that's it. And then the second option, actually, you know what, there is a very good talk in our YouTube channel about that. So the talk is there a search button? Design patterns. Yeah, so these machine learning design patterns. So Sarah there explains, talks about one of the patterns, which is about handling imbalanced data sets. Yeah, you have to trust me that one of the, yeah, so I think this is rebalancing data pattern. So you can just take a look at this, and so Sarah is explaining how exactly you can deal with unbalanced data sets. One thing to note here is, so you do this downsampling and upsampling. You do this only for your training data set. So for the validation data set and for training data set, you leave it as is. So because you want to evaluate your model. So let me just draw it. I think it's better. So let's say you have your data set, right? So you split it into like the usual 60, 20, 20. Right? So then you set the training data aside. So what you have is you have this training data set and this validation data set. So this is train and this validation. And then you can do all sorts of tricks for training data sets. So you can do oversampling. And then you can do undersampling. Oversampling. And you can check Sarah's talk for details how to do this. And then like there's techniques like SMOT for generating data sets. So you do all that, but only on the training data set. And this, so you leave this alone. So you leave it untouched. You do not touch validation data set at all. So you do all sort of things there, and then you evaluate your model on the validation data set, and you use, it's important to use precision, recall, F1 score. So you don't use accuracy here. And then here you can also experiment with different, like, okay, if I oversample the minority class, or if I undersample the majority class, which way of dealing with this works better? And then you just apply it to validation data set and see which one works better. So this is the idea. And then, of course, you like after you found the best approach, you can test it on the test data set, and you also leave the test data set alone. You don't modify it at all, and you do all this oversampling, undersampling on the full trained data set. Okay, so. If we use grid search CV for hyperparameter tuning, do we still use the validation dataset, or we use the full train dataset? Yeah, I think you use the full train dataset. So let me open the grid search CV. So this, for those who do not know, grid search CV is just a way of doing parameter tuning and selecting the best parameters, and then internally it is doing cross-validation to find the best parameters. I think there must be an example here somewhere. At the end, perhaps. Yeah, examples using scikit-learn grid search. Is there a good example? Parameter estimator using grid search cross-validation. Let's take it. Yeah, so you can just check this example. So they're tuning the support vector machine classifier, and they're tuning parameters. So they're trying different values for C, right? They're trying different values of gamma, and then for a linear kernel, this is just internal details for SVM, doesn't matter. So they're trying different set of parameters. And then what they do is they have this train test data set separation. And they are doing this. This is what we call full train here. So they are doing the fit on the full train data set, right? So they don't do the split again for validation, train and validation. So they are using the full train data set, and then grid search CV is doing the split internally. So I can probably send it to chat now, but you saw how to find it. So I think this is a cool thing. Okay, let me send it. Consider train data for which some validation needs to be separated for validation. Should EDA be done on the entire train or after splitting into validation? I don't think I understand the question, but some validation needs to be separated for. I don't know what you mean. Maybe you ask in Slack, but yeah, I think if you're not sure, just do EDA on the training data set, on the first train data set, not on the full. But if you do it on full train data set, nothing bad will happen. So how many models and how much parameter tuning are you expecting? More than one. So we covered in this course, we covered linear models, we covered tree-based models, and then in tree-based models, so in linear models, we saw the C parameter, right? Or if it's rich regression, I think it's called alpha. So you should tune that, and then you should try decision tree, you should try random forest and XGBoost, and then different parameters there, and then select the best model. So basically just going through the what we learned so far, and trying different models and then different parameter for these models. And yeah, you don't have to use XGBoost, for example. You can just use random forest. I suggest you to use XGBoost or some gradient boosting tree implementation. But yeah, just try, let's say, at least 3 different models, and then for each model, try to tune parameters. And yeah, that should be sufficient. Does use of VSGI server like G-Unicorn Waiter still required for deployment, or we can use deploy Flask app directly on cloud? I think it is required. Yeah, so it depends on the cloud. So if you want to deploy a Docker image to the cloud, then you need to put G-Unicorn or Waiters inside Docker. And yeah, because as Flask, you saw this warning, it says do not use it for production. So you do not use it for production because Flask doesn't. So the Flask developers will cry if you do this. So maybe the last one, can we check for correlation feature importance of categorical variables for numeric target? Yes, I think this is what I showed you. I'm not sure what you mean, but yeah, so I think it's a good idea to do this. Okay, so I think that's it for today. I hope you found this session useful. If you still have any questions, you can ask them in chat, in Slack. And I will share this notebook sometime later today. So not right now, maybe in a couple of hours. But I will put this, I guess, in the midterm project, and I will share it in Slack. Yes, so that's it. Have a great rest of your day and have fun with your project.